Watch this shit. Oh. A friend suggested that I build one of these after somebody else had suggested it, and somebody else, and somebody else, and somebody else. I finally did it. I can do cuts automatically.
All right, the #1 rule in home repair is safety. We're gonna rewire a major appliance. We gotta cut the electricity off, all right? Yeah, test kitchen, there we go. All right, Hank, the handyman. Come on, let's go. We gotta take off that access panel. All right. Whoa! Look at all the wires in there. Is that car running?
Are you all right, Dad?
Yeah. I did that to teach you an important lesson.
What's that, Dad?
Well, when you work with electricity, it's a good idea to shut it all off. Now, follow me upstairs. I'll show you how to treat a severe electrical burn.
Hey there, me again. Anywho, that little clip that you just saw there at the beginning, that was actually not a documentary. That was a sitcom from the 1990s. But it was just there to drive a point home. I have a question here. How is it that home distillers were so willing to accept the fact that everything that we were told about methanol in home distillation was nothing but propaganda and wives' tales, you know, from the prohibition days to get us to not do home distillation? They accepted that perfectly fine. But the vast majority of these home distillers still believe all of the same old urban legends, wives' tales, crap that their parents told them about electricity since they were a kid. And they still believe it, even though the information out there that debunks it is more easily available and easy to find than the information out there that debunks all of the methanol crap in home distillation. Is this like selective gullibility? Do people just want to believe what they were fed as a child growing up, even though it was utter bullshit? Well, here's a truth bomb for you. I hope you don't get hit by shrapnel or anything, but when it comes to distillation, you're more likely to suffer a severe injury from being scalded by steam or hot water than you are to suffer any kind of a minor injury from electricity, especially residential electricity. 120 volts, at best 240 volts. Seriously. The only way that 120 volt residential power is going to kill you is if you go take a bath with a toaster while it's plugged in, or be standing on a flooded floor barefoot and put your wet hands into a breaker box and touch the terminals where your mains come in off the pole. That's the only way you're going to die from residential electricity. Sorry, I don't know what your parents taught you, but no, you're not going to die from residential electricity unless you do one of those two things. You know, in case you're not aware of it, the electric chair that they use in executions, that runs on anywhere from 2300 to 2500 volts, depending on the state. It doesn't run off of 120 volt or 240 volt wall power. So no, you're not going to die from electrocution from residential electricity. When it comes to your still, there's no breaker that's going to protect you from steam, the side blowing out on the side of your boiler and scalding you with boiling hot water. Unlike in electrical systems, there's a breaker that's going to kick if you short something. Like I said, you're more than likely to suffer severe injury from steam, being scalded by hot water, than you are to suffer even a minor injury when it comes to residential power. And this should also go without saying, you don't work on any kind of an electrical appliance while it's plugged in, and you don't work on any kind of residential wiring, such as installing light switches, light sockets, things like that, with the breaker turned on. I mean, really. So why would a person be worried about working on their still or something like that? Why would they use this common cop-out? I'm electrically challenged. No, you're not. You have selective gullibility. You're falling for the bullshit that you were taught as a child, and you still believe that it's true. You know, it's a good thing that, well, maybe, I don't know about everybody. Hopefully you didn't grow up an orphan. Your parents didn't die before they spilled the beans about Santa Claus. Because if they did and you still, oh boy, sorry. If you're an orphan, I'm sorry, but Santa Claus doesn't exist either. I know this goes against everything that you were taught as a child growing up, and it causes cognitive dissonance, which means you have two conflicting beliefs in your head and it causes discomfort. But sorry, unfortunately, what you were taught as a child regarding electricity in your house, you dying from electrocution, it's bullshit. It's not going to happen. It's not true. That whole thing about being electrically challenged, think about it this way. When you're hooking up a sink in a house, you have three connections. You have a hot water, you have cold water, and a drain. As with residential electricity, you have a hot line, a neutral line, and a ground, which is the same as a drain. There's only three. And just like hooking up a sink, how do you screw that up? There's nothing to be afraid of. So stop using the excuse that you're electrically challenged, because it's an easy cop-out. Not long ago, I was cruising through one of these little web chat things that I'm in, and I saw a guy post this picture. I'll put it up over here on the screen so you can see what I'm talking about. He posted a picture of an air still sitting on top of an external power controller. I'm not sure if you have an air still or if you're familiar with them at all, but on the very bottom of them, they have these little cooling vents. And as you can see in the picture over here, those vents, they're clearly clogged up by the power controller that he's got it sitting on. Well, here's the problem with that. I suggested that he take the bottom off of his air still controller, or his air still, sorry. Take the bottom off of his air still and find this little device. It's called a what is that number again? Sorry, KSD1. It's a thermal snap switch. This is not a thermal circuit breaker. Circuit breakers have a button on them to reset it. This just automatically resets. It hits a certain temperature, cuts out, cools down, turns back on, and does this over and over. So this is what the air still comes with by default inside to do its temperature control. I said find this device, cut the two wires going to it, strip them back, twist them together, insulate them, and put the bottom back on. And the reason for that is so you don't have two power or temperature controllers running in series, because if they're running in series, you're never going to know which one is actually turning off the power to the air still. It's kind of like running two spam filters on an email address. You'll never know which one of them is actually responsible for putting that important email in your spam folder that you were hoping for. Same way with running two antivirus programs on a computer. You don't know which one's causing you the problem. So, in the case of this, you disconnect it, because if you're controlling things externally, there's no need to have two of them running in series. And the problem with this, these are mounted on a little bracket in the air still off to the side, and they're set, these are 150 degree. And the reason they do that is because they're not directly in contact with the boiler. So they use a lower temperature one, and it'll cut out at a lower temperature. So the way it works out is when your water hits about 212 degrees, this thing cuts out, even though it's rated for 150 degrees. And since it's not in direct contact with the boiler, it'll cut back in, because if it's a 150 degree switch, it'll turn back on at about 140, 145. But not if you have the vents closed on the bottom, because that thing's going to be trapped. All the heat's going to be stuck in there. So if this thing cuts out when it reaches 150 degrees, good luck figuring out which one is causing you problems if you're not aware that these exist. Well, he used that excuse that he's electrically challenged. I'm going, Jesus, tap dancing Christ. All you got to do is cut 2 wires, strip them back, twist them together, put some tape on them. Electrically challenged? You put more effort than that into, Jesus, trimming your ear hair. I'm serious. So it's a cop-out. You know, the guy, he's not electrically challenged. He just doesn't want to put any more effort into things than what he actually has to, because his parents growing up have convinced him that electricity is dangerous. You're going to kill yourself. You're going to set your house on fire, even though there's a breaker that's going to kick if you do short something. And what's the worst that's going to happen if things short? A couple plasma sparks and then the breaker kicks. The worst you're going to do is scare yourself, and there's really nothing to be scared of. You can't kill yourself with residential power unless, like I said, you go take a bath with a toaster that's plugged in, or you're standing on a flooded floor and you put your wet hands into your breaker box. Come on, people. Seriously. Here's another example of somebody making shit entirely too complicated for themselves for no good reason whatsoever. This is one of my airhead kits. I sent one of these to a guy. I got to send this one off tomorrow. And told him that, you know, there's only 4 connections here. It's not hard. There's 2 that go to the power supply, a hot and neutral, and then 2 here that interrupt your power to your heating element. That's it. 4 connections. Not rocket surgery. I don't know what he did, but he finally put me on a Google Meet, which is Google's little video chat thing, so I could see what he had done and hopefully coach him along the way. But unfortunately, the camera spent more time pointed at the ceiling or laying face down on the table. I couldn't see shit. And when I did finally see what he had done, there was nothing left inside of that air still other than the heating element and the 2 jacks on the back for the power in and the power out. So I said, okay, we're going to start over from scratch here since you've already pretty much vandalized your air still. So I drew him up a little basic diagram, took a picture of it, sent it to him, and there's nothing to this. Here's your power lines, your power jack coming in, going through your switch straight to the fan port. So you can turn your fan on and off so you know you have a functioning circuit. We're going to add 2 hots and 2 neutrals to it later because we need them for the power supply and the heating element. Never did hear anything back from him. I'm positive he never got it hooked up. So now, due to him milking that I'm electrically challenged cop-out and being too afraid to do even the most basic level of wiring, and it's not dangerous wiring because it's only residential wiring, and you have circuit breakers that's going to protect you. Well, he's now stuck with an air still that won't work. He's stuck with airhead brain for it that he's just too damn chicken to hook up, and it's 4 goddamn wires. I don't get it, people. I honestly don't fucking get it. So that's about all I have for this video. I just wanted to make it clear that there's no reason to ever say that you're electrically challenged. It's 3 wires, it's hot, neutral, and a ground, just like hot water, cold water, and a drain line going to a sink. It's not complicated. You're not going to kill yourself. Just quit making excuses. Because if you keep making excuses, you're always going to be dependent upon somebody else, or you're going to settle for just living with the problems that you have, even though you could fix them right now if you really just wanted to. So that's all. See you next time. I'm going to go back to playing with my little toy here. Let's see. Previous jar. Oh, there it goes again. Have a good one. See you next time. Bye.